This chapter is the beginning of probably the most important unit that we'll be working on this entire semester, because now we can take what we know from a sample, we can put it together with probability and use that to figure out what that tells us about the whole population. So that's what we will be doing in all three of the remaining chapters, talking about based on a sample, what do we know about the whole population. So in this section, we'll be doing that for proportions and percentages. Based on a sample, what do I know about proportions and percentages for the entire population? So just a reminder, proportions can be written as decimals, fractions, and percentages. So you may hear the terminologies, proportion, probability, percent, and you may see the notations using fractions, decimals, and percentages. All of these are essentially the same thing. A little bit of notation. We'll use P to represent the proportion or percentage for the entire population. X will be the number of successes. We've actually used that before with the binomials. And then we've got P hat, which is the proportion for a sample, and then Q hat, which is the opposite. It's the complement of that percentage. So if P hat is how many people do something, then Q hat is how many people don't. And we're going to use some new terminology to talk about the sample. We're going to use the phrase point estimate. The point estimate is what's going on in your sample, the statistic from your sample that may give you some idea what's going on in the whole population. So in this case, P hat is our proportion or percentage from the sample, and that is what we call our point estimate. And so what we're going to be doing in this chapter is saying, okay, so based on that point estimate, I don't really think that the whole population is going to be exactly the same as my sample, but I'm hoping it's probably going to be pretty close. So we have something called a confidence interval, and it's a range around that point estimate that we think the whole population probably is in. So if I've got an example here. Let's say you tell the person you live with that you think you're going to be home around 6:30. Well, that would be like a point estimate. But if you said probably between 6 and 7, as opposed to being specific and saying 6:30, then that's more like a confidence interval. So it's the range in which we think that the whole population probably falls based on what we saw in a sample. Now we have talked about how, depending on your sample, different samples could also have different values. And that's okay. We'll use a sample to generate a confidence interval. If you used a different sample, you might get a slightly different confidence interval. But in general, all of those confidence intervals would overlap somewhat, and most likely the real value is in there somewhere. Now, it is possible to be wrong if you get a weird sample and you base all of your calculations on that. You could be way off, but we will be sure to a certain percentage that our sample has given us an interval that will work. That percentage is called a confidence level. So that's how sure you are that the interval you've generated based on what happened in your sample is a correct interval that really does have the population value in it. So we usually have confidence levels that are in the 90s, though not always. And the higher the confidence level, the wider the interval will be to be sure that it's correct. So in this example, I'm just going to talk about if you see a confidence interval, what does it tell you? So we have a Gallup poll. 491 adults were asked about their opinions on the death penalty. 65% said they were in favor. 95% confidence interval was generated, and it said that P, the population value, is somewhere between 60.8% and 69.2%. Okay, so the 65% from the sample, 65% of the people in the sample were in favor. That is P hat because it's from the sample, and that's our point estimate. We think that the population's probably close to 65%, but the population probably won't match the sample exactly, so we generated a confidence interval. And this confidence interval was generated with 95% confidence. So that means we are 95% sure that the actual percentage for all adults, meaning the population. So we're pretty sure that for all adults, the percentage in favor of the death penalty would probably not be exactly 65%, but probably between 60.8% and 69.2%. And pay attention to the way I've got the phrasing on the screen. There are some important pieces there highlighted in red. You do need to say the percentage of confidence, how confident you are, whether you're talking about a percentage, proportion, or later we'll be talking about means. So mention that. And then mention that you're talking about the population in some way. So usually to indicate that we say all so-and-sos. So you need to say we are 95% confident that the percentage for all adults that are in favor of the death penalty is between whatever your confidence interval values are. Before we talk about how to actually calculate these confidence intervals, there are some things that you need to check to make sure that the calculation will be accurate. The methods that we use are only accurate under certain conditions. So you need to find the p-hat. Sometimes you'll have to calculate that, sometimes it will be given. And then you're going to use that as an estimate for the population. And so you need to check that if that's talking about a group of people that said a particular thing, you need to make sure that that comes out to more than 5 people. And then you also need to find out if there are more than 5 people in the other group. And I will run through an example to tell you what I mean by that, because that sounds a little weird until you see an example. Okay, so in this example, let's say on a survey, 23 people say yes to whatever question you asked and 77 people said no. Well, without even going any farther, this one has actually told me how many people are in each group, so I can actually see that there are more than 5 people in each group. 23 people said yes, that's more than 5. 77 people said no, that's more than 5. So this particular scenario would actually be okay to calculate a confidence interval on. And then I just showed the calculations of the percentages here, but actually to check the over 5, in this particular case you wouldn't need that. You would need those percentages for the rest of the problem. Now sometimes you're not told the actual numbers, you're given the percentages instead. And so in this example, let's say 100 people were randomly chosen and tested for HIV, 2% tested positive. So we need to know, is that more than 5 people? So they didn't tell us the number of people that tested positive, they just said 2% out of a sample of 100. So we need to calculate that real quick. So there at the bottom I say check NP equals, so I'm taking the number of people in the sample, which is 100, and I'm multiplying it by 2% to find out that that's actually 2 people. So 2 people tested positive in this case, which would mean 98 people tested negative. Well, the 2 people that tested positive do not create a large enough group for these calculations that we're going to do. So in this case, you would have to say that you could not continue with the problem. So let's say you've decided that you're working on a problem that you can continue on. Let's talk about how to do that. So in the calculator, we're going to start using a new menu. You'd go into the Stat button and arrow over to the Tests menu. And then for what we need for the confidence intervals, you need to scroll way down and look for choice A, which says 1 prop z int. That's a 1 proportion z interval, which is what we need to find because we're doing confidence intervals on a proportion. It will call up this screen that you're looking at, and it's nice because the screen actually walks you through what you need to tell the calculator. So it'll say X. X is the number of people in the group that you're looking at. N is the total number in the whole sample. So X is the group that said a particular thing. N is the whole sample size that you looked at. And then the confidence level goes in as a decimal. And then you take your cursor down to calculate and hit enter to run the program. When the calculator gives you the confidence interval, it will give it to you as a decimal. Remember, that is a proportion which could be changed to a percentage if you wanted. These are the same as probabilities as well. So probabilities, percentages, proportions, anytime you're talking about those kinds of things, we're going to round to 3 significant digits, which is the same rounding rule from the last unit when we were talking about probabilities. You can write confidence intervals 2 different ways. You can write them with the notation of the P in the middle and then the less than signs on each side to say what you think the population proportion is between, or you will notice that your calculator uses parentheses notation. It's an interval notation where it just puts the 2 numbers in parentheses. That's what I tend to use the most often. This is a flow chart that some people find helpful, especially by the end of the chapter when we have done some different cases. But at the top it says, what are you trying to find a confidence interval for? Well, we're talking about proportions right now, so you'd go down the right-hand side for the P. It has you check if there's at least 5 in each category. If so, you can use your 1 prop Z interval. If not, you can't continue with the problem. So you'll see this flow chart pop up again in the other sections in this chapter. I am going to cut the video here, and then in the next video I'm going to come back and do some examples for you to make this all a little bit more clear, hopefully.